Every modern civilization rests upon invisible laws. When a plane takes off, when a bridge stands firm, when a satellite remains in orbit, or when a phone calculates motion and force, the same principles are quietly at work. These principles were first unified by one man, Isaac Newton. More than any ruler, general, or emperor, Newton shaped the modern world through ideas alone. His laws governed science for over 3 centuries, forming the backbone of physics, engineering, astronomy, and mathematics. Even today, much of our technology operates within Newton's framework. Yet Newton himself lived a life far removed from fame or admiration. He was secretive, intensely private, emotionally distant, and often tormented by inner conflict. To understand his discoveries, one must understand the man, because Newton's science was born from isolation, obsession, and a relentless pursuit of absolute truth. Isaac Newton was born on December 25, 1642, in Woolsthorpe, England, into a world that seemed determined to reject him. He was born prematurely, so small and fragile that his survival appeared unlikely. His father had died months before his birth, leaving Newton without ever knowing him. When Isaac was only 3 years old, his mother remarried and moved away, leaving him behind with his grandmother. This abandonment left a profound psychological imprint. Newton grew up feeling unwanted, isolated, and emotionally detached. As a child, he rarely played with others. Instead, he built models of windmills, water clocks, and mechanical devices, carefully observing how motion and force interacted. Even at a young age, Newton showed an instinctive fascination with systems, structures, and hidden mechanisms, as if he were already preparing to uncover the machinery of the universe itself. Newton's early school years were unremarkable. He was shy, socially awkward, and frequently bullied. One particular incident, where a fellow student physically attacked him, ignited something powerful inside Newton. Instead of responding with violence, he responded with ambition. Newton dedicated himself to academic dominance. He studied relentlessly, memorizing texts, mastering mathematics, and surpassing his peers. This pattern, transforming emotional pain into intellectual obsession, would define his life. In 1661, Newton entered Trinity College at Cambridge University. There he immersed himself in the works of Galileo, Kepler, and Descartes. But Newton did not admire them blindly. He criticized their assumptions, searched for contradictions, and attempted to rebuild their theories from first principles. He slept little, worked obsessively, and filled notebooks with ideas far beyond the university curriculum. Newton was not seeking knowledge. He was seeking certainty. In 1665, England was struck by the Great Plague. Universities closed, cities emptied, and fear spread rapidly. Cambridge sent its students home, effectively halting academic life. For most, this interruption was devastating. For Newton, it was liberating. Isolated at Woolsthorpe, free from lectures and distractions, Newton entered an unprecedented creative phase. Over the next 2 years, he developed calculus, formulated the laws of motion, discovered universal gravitation, and revolutionized optics. He worked entirely alone, without laboratories, mentors, or collaborators. These discoveries were not incremental. They were foundational. Newton later referred to this period as his most productive, a time when ideas seemed to flow effortlessly. Historians now recognize this as one of the most extraordinary bursts of intellectual achievement ever recorded. One of Newton's most revolutionary achievements was the invention of calculus, a mathematical system designed to describe continuous change. Before calculus, mathematics struggled to describe motion, acceleration, and curves accurately. Newton needed a new tool to analyze how objects moved under varying forces. Calculus allowed him to calculate instantaneous speed, changing forces, and curved trajectories. Although Newton developed calculus independently, he delayed publishing it, fearing criticism and conflict. This hesitation later sparked a bitter dispute with German mathematician Gottfried Wilhelm Leibniz, who also developed calculus independently. The controversy over who invented calculus became one of the most intense scientific rivalries in history. Despite the conflict, calculus became indispensable to science, engineering, economics, and modern technology, a silent engine behind nearly every scientific advancement since. Perhaps the most iconic moment in scientific history occurred during Newton's time at Woolsthorpe. Observing an apple fall from a tree, Newton questioned why it fell straight downward rather than sideways or upward. This simple observation led to a profound realization. The same force pulling the apple to the earth must also govern the motion of the moon. Newton concluded that gravity is universal. Every object attracts every other object. This insight shattered centuries of belief that celestial motion followed different rules from earthly motion. Newton's law of universal gravitation unified the heavens and the earth under a single mathematical principle. With one equation, Newton explained planetary orbits, tides, falling objects, and celestial motion. The universe suddenly became coherent, predictable, and mathematically ordered. Newton's three laws of motion transformed physics from philosophy into precision science. The first law described inertia, explaining why objects resist changes in motion. The second law provided a mathematical relationship between force, mass, and acceleration. The third law revealed that forces always come in equal and opposite pairs. These laws allowed scientists and engineers to calculate outcomes before they happened. For the first time in history, humans could predict how machines would behave, how projectiles would travel, and how structures would respond to forces. From clocks and engines to bridges and cannons, Newton's laws enabled technological advancement on an unprecedented scale. Even modern spacecraft navigation relies heavily on Newtonian mechanics. Newton's work in optics was as revolutionary as his work in mechanics. At a time when most believed white light was pure and colors were created by materials, Newton proved that white light is a mixture of all colors. Using prisms, he demonstrated that color is a fundamental property of light itself. This discovery changed the understanding of vision, perception, and optics. Newton also invented the first practical reflecting telescope, replacing lenses with mirrors to eliminate chromatic distortion. This design became the foundation of modern astronomy. His optical research revealed that even the most familiar aspects of reality, light and color, obey precise physical laws. In 1687, Newton published Philosophia Naturalis Principia Mathematica, a book that fundamentally altered human thought. Written in dense mathematical language, the Principia laid out the laws of motion and gravitation with unprecedented rigor. It demonstrated that nature operates according to universal mathematical principles. The book was difficult to read, yet its influence was immediate and profound. It became the foundation of classical physics and guided scientific progress for centuries. The Principia did not merely explain nature, it showed that the universe itself could be understood as a mathematical system. Despite his brilliance, Newton was deeply troubled. He was paranoid, secretive, and often cruel to rivals. He held grudges for decades and engaged in vicious disputes. He suffered mental breakdowns, likely exacerbated by isolation and mercury poisoning from alchemical experiments. Newton spent years studying alchemy and theology, believing hidden truths were encoded in ancient texts. To him, science was not separate from spirituality. It was a way to uncover divine order. Newton died in 1727 and was buried in Westminster Abbey, honored as one of Britain's greatest minds. His influence continues to shape modern civilization. Newton showed humanity that the universe is governed by laws, and that the human mind is capable of discovering them.